This is an update of where we are production wise. At the top there is two stators. I've opted to put in two as opposed to one, mainly because the design is such that the two stators at the bottom there will accommodate two rotors, and the rotors are 1008 millimeters wide. The width of the stator, the box will be square, and it'll be 1216 millimeters wide, and that enables the production of a longer model so that you can put in as many stator rotor combinations as you wish, because they're only 81 millimeters plus 40 mils separating these rotors, and the same for the stators. So what you'll be able to do is make them as long as you wish, and just to increase the horsepower. Now they have to retract out of, the rotor has to retract out of the stator, because when you push them together they start to rotate, and they just keep on getting higher and higher and higher. So we have to come up with some way of limiting the speed, possibly with a hydraulic pump, and using it as a limiter to keep the RPMs down to about 2,400 RPMs to line up with the alternator speed required. So I'll just go down there and lift it up and show you how light it is. So that's going to move down into the stator box here. So there's roughly 121 mil centres. So 121 mil to the next one, 121 mil, 121 mil, so forth. So it's possible with the available materials, 3.6 mils, 3.6 metres long, you can stack these as long as you like. You could put 20 in there or so. So if you're getting, let's say conservatively, you're getting 200 horsepower out of each one. You put 10 in, you got 2,000 horsepower. And the central hub, that can be increased to any size diameter of shaft you want. And then you can reinforce it with stainless steel plate or whatever, because the forces aren't quite extreme. And this is what the new technology, or the physics breakthrough that I've made, allows you to do this sort of thing. And you could drive a water pump, for example, from a lake, drive the water up 200 or 300 feet into a giant holding tank, and then run the water off that down into a series of turbines, just like they do in the hydro schemes. Snowy Mountains in Australia, for example, does that sort of thing, or in Canada they do that type of thing, British Columbia. So it's lends itself to a either direct drive onto a series of generators. I've had several ideas of how to control the RPMs, because it's just getting to the point where it is it just keeps on revving. So you could load her up to a hydraulic drive, and that'll limit the speed. And there's possibilities that the generator manufacturers can take care of any RPMs you want to put into it, and limit it when you hook it up to the grid to the particular cycles that you need. And generators will do that. They will line up with the speed of the cycles. If it's 50 hertz or 60 hertz, you can put a generator online and it'll try to go faster, but be limited by the cycles of the hertz itself. And there's many things you can do. Drive, for example, DC generators, and then convert it to hydrogen, and then the hydrogen can run a diesel generator. So you can capture a great deal of power just by using water. So have this convert the DC power into a hydrogen converter, then run the hydrogen straight into a diesel, and you'll probably get a 10 times the ratio of power that you would produce directly making this into a generator hooked to a electrical grid. So there's many potentials you can do with it.